Hey, algebra students, in this lesson, we are going to be adding and subtracting fractions. But these aren't like the fractions that you're used to adding and subtracting when you were doing arithmetic. They're kind of the same. The big difference, though, is that we're going to be using variables in our fractions. And as always, we have to be on the lookout for things that we can factor, especially trinomials that can be factored. Now, here's the thing that's similar. You noticed when you were doing arithmetic that in order to add fractions, you had to have the same number on the bottom of the fraction. We call it a common denominator. If you didn't have a common denominator between two fractions, you couldn't add them until you made a common denominator. And how did you make a common denominator? You multiplied the top and the bottom of the fraction by some number. It had to be the same on the top and the bottom. That's one of the requirements. We'll talk about why in just a moment. But you multiply the top and the bottom of one of the fractions by the same number, or maybe even both of the fractions, and you get the same number on the bottom. And then by doing that, you can add the fractions because now they have a common denominator. We're going to be doing that same thing, but ours are going to be a little more complicated than what you've done in the past because we have to figure out what our fractions are missing with variables in order to be able to add them. So we're going to dive right into the homework. I'm going to explain to you why this works the way it does, which fractions can be added, which ones need to be adjusted first before we add them. Let's get started. Letter A, we have the fractions 4mn over 24m plus 11mn over 24m. And the question is, are we able to add these fractions together? We can add these two fractions because they have the same denominator. So let's take a look at what this looks like. Over here, I'm going to write letter A, and then we're going to add the fractions 4mn, and then it's going to be over, so I need to put a fraction bar in. That's going to be over 24m. There's a plus sign between our fractions. I'm going to put that in right away. 24m plus, and the second fraction is 11mn over 24m. Now, because we have the exact same thing in the denominator on both fractions, I can just add fractions the same way I've always added fractions. And the way you add fractions is add what's on the top and then leave alone what's on the bottom. Like 3/5 plus 1/5 is 4/5. It's not 4/10. I just leave alone what's on the bottom. So as long as I can add what's on the top, and you're going to have to use all your rules for what you can add together, 4mn's plus 11 more mn's make a total of 15 mn's. And this is going to be 15mn over 24m. All right, now it would be nice if we were done, but these problems are a little bit more complicated. We need to ask ourselves if there's anything that can be reduced in the numerator and denominator. Do I have any factors in common in the numerator and denominator that can be canceled? I see yes, I have an m in the denominator and an m in the numerator. Those will cancel each other out. Also, 15 is 3 times 5. 24 is 3 times 8. That 3 is in common between the numerator and the denominator. So I'm going to reduce this by a factor of 3, reduce this by a factor of 3, and then I am finished. I cannot adjust this any further. 5n over 8 is the answer for the first one. Let's just double check. There we go. Let's do letter B, another easy one to get us started. Okay, so in letter B, we have 7y minus 2. Okay, there's going to be a minus sign in between our fractions. I'm going to put that in right away. Y minus 38 on top. And then let's make our fractions and we'll make our denominators. Hey, I'm going to notice in this one, our denominators are the same. Okay, so our denominator on this side is going to be y plus 6. Y plus 6, and our denominator on the other side is y plus 6. Now, immediately when I see a variable plus a constant, I'm asking myself, I wonder if that's going to factor out somehow. Let's find out. Now, the rules for adding and subtracting fractions haven't changed. I'm going to subtract across the top, leave the bottom alone. Subtract across the top. Now, what am I subtracting? Well, this minus sign means it's minus the expression y minus 38. So let's write this out. It's going to be 7y minus 2 minus the expression y minus 38. And then when I actually do the subtraction, this negative is going to distribute to these two different terms. So it's going to be minus y plus 38. See how that minus changed the signs of both things here? Okay. And I'm just going to go ahead and do my combining right away. So this is going to become 6y. That gets rid of, because it's 7y minus y is 6y. 38 minus 2 is 36. So this is going to be plus, because 38 is way bigger than negative 2. So this would be plus 36. 6y over 36 over, what do I do with my denominator? Is it 2y plus 12 or is it 0 because I'm subtracting? It's y plus 6. The denominator stays the same. The denominator does not change when you add or subtract a fraction. Okay, you got to remember that. Hey, it looks like I'm done, but wait a second. I always have to be on factor patrol. Can anything be factored out of the numerator? Why, I could pull a 6 out of 6y and a 6 out of 36. They have a common factor. Let's pull out that 6. If I pull the 6 up front, I get 6 times y plus 6. 6 times y plus 6. And then wait a second. Notice that I have y plus 6 on top and y plus 6 on the bottom. Those are going to cancel because I have the same factor on the top and the bottom. So what I'm left with here is just 6. The answer to letter B is the number 6. Everything else cancels. So look at this big expression we started with. Sometimes they're going to simplify to something really simple. All right, letter C. In letter C, let's see, on top, and I'm just going to do my addition right away this time because I'm getting good at this. I know the bottoms are the same. I'm just going to double check. Everything on the bottom of both fractions is the same. So this is going to be d to the fourth. Oh, hold on. Let's get our text box in, and then we're going to do letter C, d to the fourth plus 2d cubed plus 2d cubed, another 2d cubed. And that's all going to be divided by the same thing that was on the bottom to begin with. So it's going to be divided by d. Hold on one second here. It's going to be divided by d squared minus 5d minus 36. Okay, now I see a couple of things stand out. I have a trinomial on the bottom. If I have a trinomial on the bottom, that trinomial on the bottom is certain to be factorable. Almost positive I can just factor that. Also, on the top, I can combine this 2d cubed plus 2d cubed. Let's see, if I have 2d cubes and another 2d cubes, when I add those together, they're going to add to make 4d cubes. That's what I have on top of this fraction. Okay, so this is my fraction that I'm going to be dealing with. Let's see, how can I manipulate this? I'm going to just copy this. Let's see, we'll copy it one part at a time. We'll copy the top over here, just so I could see what I'm originally working with here. Okay, so this is the top, and then I'm going to copy the bottom over here, and then we're going to make some adjustments to it. First thing I notice on the top is I can factor out d cubed. So if I factor out a d cubed and put d cubed in front, that means I have to take a d cubed out of each of the terms. So this is, instead of d to the fourth, this is going to be d. And instead of 4d cubed, this is just going to be 4. So on top of my fraction, I have d cubed times d plus 4. On the bottom of my fraction, let's see, let's say I need to find factors of 36 that negative 36 that add up to negative 5. So the obvious factors of negative 36 are 6 times 6, but that's not going to add up to negative 5. I do have other factors, though, like 3 times 12. I don't think that's going to do it. Ooh, 4 and 9, though. 4 and 9 have an ability to add up to 5 if one's negative and one's positive. Remember, I need to make them add up to negative 5, so I need to make sure that it's, let's see, this is going to be d plus 4 times d minus 9. because 4 times negative 9 is negative 36. 4 plus negative 9 is negative 5. So this is going to FOIL out to d squared minus 5d minus 36. But what do you notice? Notice on the top of my fraction, I have a d plus 4. Bottom of my fraction, d plus 4. That means that my answer is going to be d cubed over d minus 9. Let's just double check that we're right here. D cubed over d minus 9. There it is. Okay, letter D. So are these complicated? You're probably noticing like there's a lot of steps to these, and you got to remember to factor things. That makes these a little bit complicated. Letter D is the same sort of thing, except now we're going to add in one more level of complication. I don't have common denominators. Huh, what am I going to do if I don't have common denominators? I'm not able to add. One of the first things you could do is just reduce your fraction and see if when you reduce your fraction, you get common denominators. Let's give that a try first. So for letter D, I start with negative 3p over 6p squared plus 2p cubed over p to the fourth. Just noticing I do not have common denominators to start out here. All right, let me just add my fraction bars, and we'll go ahead and add what's under the fractions here. So we got that one, we got this one. All right, and let's get going. Under the fractions, we're going to have, let's see, on this one, we have 6p squared. On the other one, we have p to the fourth. Okay, now I'm going to see if I can just reduce anything out of these fractions. So I'm going to notice that this one, negative 3 on top and 6 on the bottom, I can cancel a 3 out. It becomes negative p on top, and cancel a 3 out of 6, I get a 2 on the bottom. Okay, so that helped. It didn't solve any problems, but it kind of probably helped. I notice I have a p on top and a p on the bottom here. I'm going to get rid of this squared because I have two, basically p times p on the bottom and p on top. One of these p's on the bottom is going to cancel out my p on the top. Now, I have nothing left on top of this fraction. There has to be something on top of the fraction. So the implied value that goes on top is 1. This is negative 1 over 2p. I'm going to cancel my p's the same way here because I have 3 p's being multiplied on top, 4 p's being multiplied on the bottom. 3 of these p's are going to cancel out 3 of these p's on the bottom, and I'm negative 1 over 2p here plus 2 over p here. Now, can I add these fractions yet? The answer is no, not yet, because I have different denominators. But now, what can I multiply this second fraction by to get the same denominator in both fractions? Well, here's something that you can always do. You can always multiply anything in algebra by 1 and get the same value that you had before, right? If I multiply 6 by 1, I have 6. If I multiply 3 by 1, I have 3. I can multiply by 1, but I'm going to multiply this by a fancy version of 1. Instead of multiplying by 1, I'm going to multiply by 2 over 2. Okay, so I'm going to put an extra factor of 2 on top. Let me just put that in parentheses so it's obvious that I'm multiplying. And then I'm going to put an extra factor of 2 on the bottom. I just multiplied the top and the bottom by the same thing. Now notice I could, if I wanted to, cancel those 2's out and turn this back into 2 over p. I didn't change the base number by multiplying the top and the bottom of the fraction by the same thing. But what does this do for me? The top here changes to 4. The bottom changes to 2p, and there's my answer. Now I can add these because I have the same denominator. If you don't have the same denominator, you have to get the same denominator, okay? So now I'm going to just go ahead and add these. Negative 1 plus 4 is 3. And then on the bottom, 2p stays with me. It's not going to go anywhere. Remember, anytime you add a fraction, the denominator stays the same. My answer is 3 over 2p. Let's just make sure we did that one right. All right, so we've added a new element. You can multiply the top and the bottom of a fraction by the same thing if you need to get a common denominator. Let's continue with letter E.